Today, many artificial satellites built in India are circling the Earth in various orbits. Through their services, they have improved the quality of our life and made it safer. But there is one Indian satellite that is different from these space-based assets of India, which is patiently waiting for its launch. Instead of using its vantage point in space to look down at the Earth, this satellite will focus its attention towards the heavens to help enhance our knowledge about the universe. This is Astrosat, India's first dedicated multi-wavelength orbiting astronomical laboratory.
In the country, there is definitely an atmosphere where more and more science students and studies are being encouraged in the country. Now, what happens is, so far the scientific community needed to get the data from the satellites which have been launched by others, whereas Astrosat is going to be one of our own indigenous satellites, and we are also going to provide on this particular satellite program a capability to the country where students and researchers can decide what particular celestial object they want to observe.
From time immemorial, humans have gazed at the night sky with wonder. Night sky observation was the beginning of human endeavor to understand the universe. India has a long tradition in astronomy. The famous ancient Indian astronomer Aryabhatta stated that the occurrence of day and night is due to Earth's spin motion about its own axis. Besides, he opined that shadows were responsible for eclipses. Later, the Bhaskaracharyas Varahamihira and Brahmagupta made notable contributions to mathematics and astronomy. Much later, the Renaissance facilitated the detailed scientific explanation for the happenings in the sky. Different types of electromagnetic radiation help us understand different aspects of the universe. While infrared waves enlighten us about the dim stars as well as star and planet formation, the ultraviolet rays provide information on very hot stars. Similarly, X-rays and gamma rays provide information on extremely violent events in the universe like supernovae or the devouring of starry material by a black hole. And microwaves help us understand the formation and evolution of the universe. Thus it became essential for humans to launch instrumented platforms to outer space for a comprehensive observation of the universe in different regions of the electromagnetic spectrum. Satellites carrying scientific instruments capable of studying those radiations behave like space observatories, facilitating the detailed understanding of the universe. After the dawn of the space age on October 4th, 1957, humans have launched many scientific satellites capable of studying different regions of the electromagnetic spectrum. Those satellites have enormously enhanced our knowledge about the working of the universe.
The launching of the first Sputnik in 1957 from Russia, which started the actual space science exploration in a big way, was an important milestone in our exploration. Since then, of course, many satellites were made, and in the beginning particularly most of the satellites were meant for looking at the space and the space sciences.
India today is a prominent spacefaring nation. The Indian Space Research Organization, ISRO, has vast experience in building and launching a variety of satellites and utilizing them for many national developmental tasks. In the past 4 decades, many scientific spacecraft missions have been successfully conducted. In fact, the very first Indian satellite, Aryabhatta, was a scientific satellite. Astrosat is the next major space science endeavor of ISRO. Astrosat mission envisages an Earth-orbiting scientific satellite with payloads capable of simultaneously observing the universe in the visible, ultraviolet and X-ray regions of the electromagnetic spectrum. Thus, Astrosat is a multi-wavelength space observatory of India. It is expected to further enhance our knowledge about many interesting processes in this universe.
You get a global recognition because ultimately when you do good science, it receives global recognition. When you do a good satellite, it gets a good national recognition.
The cuboid-shaped Astrosat, covered with a golden-colored thermal blanket, weighs about 1,500 kilograms. Control system of the satellite acts like its electronic brain and provides the stability for the satellite to focus its attention towards a target of interest or to change its orientation. Fast-spinning reaction wheels or small rocket engines called thrusters actually perform this job based on the instructions from the control system. All these highly sophisticated equipment enable Astrosat to perform its astronomical observations flawlessly.
Though this is one of the satellites ISRO has built, this has its own uniqueness. The uniqueness being this is predominantly the science the satellite meant for the astronomy observations of multi-wavelength. And as far as the engineering and construction point of view, it has given a fairly good challenging opportunities for ISRO.
Astrosat is scheduled to be launched into a 650-kilometer orbit inclined at an angle of 6 degrees to the equator. The task of launching Astrosat to that orbit is entrusted to the Polar Satellite Launch Vehicle PSLV, the workhorse launch vehicle of ISRO. The XL version of the PSLV, which is chosen to launch Astrosat, weighs 320 tons at liftoff, and this mission is designated as PSLV C-30. This will be the 31st launch of the versatile PSLV. It takes about 23 minutes for PSLV C-30 to place Astrosat in its designated orbit. Along with Astrosat, 6 smaller satellites from Canada, Indonesia and the USA, together weighing 118 kilograms, are scheduled to be launched by PSLV C-30. Once it is separated from the 4th stage of PSLV, Astrosat begins its independent orbital life and after a few days will be ready to begin its assigned task of observing the universe in the visible, ultraviolet and X-ray regions of the electromagnetic spectrum.
These observations can be done for imaging, can be done for spectral studies, can be done for high time resolution studies. This makes us to understand the physical processes in the sources, different galactic sources, also their time varying behavior. So this is the basic objective of Astrosat.
The Ultraviolet Imaging Telescope UVIT is jointly developed by Indian Institute of Astrophysics at Bangalore and Inter-University Centre for Astronomy and Astrophysics at Pune, in collaboration with the Canadian Space Agency. This instrument is capable of observing the sky in the visible, near ultraviolet and far ultraviolet regions of the electromagnetic spectrum. Large Areas X-ray Proportional Counter LAXPC, the second payload of Astrosat, is designed to study the variations in the emission of X-rays by a type of binary stars known as X-ray binaries, as well as to study other cosmic X-ray sources. It can make measurements of the spectral features of different classes of X-ray sources over a wide spectral range. LAXPC has nearly 5 times more effective area for collecting X-ray photons with energy beyond a certain range compared to another similar scientific satellite mission from abroad. Soft X-ray Telescope SXT of Astrosat, developed by TIFR along with the Inter-University Centre for Astronomy and Astrophysics and University of Leicester, UK, is designed for studying the variations in the X-ray spectrum of a lower X-ray energy range emitted by distant celestial sources. This payload has a 2-meter focal length telescope with thin conical gold-coated aluminium foil mirrors. These special mirrors reflect X-rays that are incident on them at a very shallow angle. The focal plane camera of this instrument has a cooled charge-coupled device. Cadmium zinc telluride imager CZTI, yet another Astrosat payload functioning in the X-ray region, extends the capability of the satellite to sense X-rays of high energy. This payload may also be able to detect gamma ray bursts and study their characteristics. CZTI payload is developed by TIFR in collaboration with Inter-University Center for Astronomy and Astrophysics and ISRO. The fifth payload of Astrosat is the Scanning Sky Monitor SSM, developed by ISRO Satellite Center at Bangalore, along with the Inter-University Center for Astronomy and Astrophysics. This instrument is designed to scan the sky for long-term monitoring of bright X-ray sources. It is capable of detecting and locating objects that emit the bursts of X-rays during a very short period. Such extremely brief sources of X-rays will then be studied in detail by other instruments on Astrosat. Astrosat was realized with the participation of all the major astronomy institutions and some of the universities in India. It is the first satellite mission to be operated in India as a space observatory. Having patiently toiled to develop different sensitive scientific instruments of Astrosat to better understand the universe, Indian astronomers have a sense of satisfaction after their successful integration with the satellite under ultra-clean conditions. The satellite has completed its slow journey over land to its launch center at Sriharikota and is getting ready to take a rocket ride to space to begin its long-cherished look at the vast cosmos.